In this video, I'm going to teach you how to write a assembly language program to add an array of 16-bit numbers and store 32-bit result in internal RAM of forum LPC 1768. So you can start writing the program itself. For how to create project and all, you can refer step-by-step tutorial of my video. So to add the new file, okay, you have to go to project source group, add new item to the group, select ASM file and write add array. Okay, add array 16-bit or something you can write, and dot s you have to write and save. Okay, click on add, it will add. So if you add, if you will get a blank editor window, there you have to type this program. So first line you can write a comment like semicolon, and you can write a comment as write a program to add array of 16-bit numbers and store the 32-bit result in an internal array, internal RAM, or you can also write the TTL. TTL stands for title. Without comment, you can write the TTL means it will consider anything followed by TTL as a title for that program. Or if you want, you can comment that line like putting on semicolon. So next, the program starts the area, which is addition of 16-bit array. No, so you can give label as addition or add array or something you can give, and this area is actually of type code, which is read-only memory. So next line is export space. You have to give some space between export and underscore main. Two times you have to press underscore. So shift minus button. So two times you have to press. So after that small main main. So next line, fourth line, you have to start without space. I already told for labels, no space is required in the beginning. For other instructions, at least one space you have to give. So minus, underscore main is a label, okay, which is there in the startup file. In the line number 127, you can, and 28, you can see import underscore main. So in the startup file, actually it will import the address of underscore main. So that's why in our program, uh, we are having this file. Okay. So let me remove the old file and I will add this file now. So this is an existing file. So you can create a new file or you can create existing file. Okay. So next, LDR R not is equal to array. So we have to load the address of array. So this array is a data is declared here. So again, one more area is actually given a name as array data, and it's a code. It's a data, or you can remove this line, no problem. You just remove it. Only one time is sufficient. That is not required actually, because that is also comes under code area only, which is read only. Okay, area addition code read only, no. So there only it will come. So it is an array which is declared as DCW, define constant word. So it is a 16-bit data. 0011 means in 16-bit, it is actually each hexadigit you have to write in 4 bits. Okay, 0 means 40 binary, 1 means 0001. Okay, 2 means 0010, 3 means 011, 0011, 4 means 0100, 7 means 0111. So like that you have to write any I think how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 16-bit datas are there. So you can declare as define constant word data. Okay. DCD means define constant double word data. Define constant data. It is 16-bit. So word is sum is actually 16-bit. We have to write in some location which is defined as 32-bit. Because 16-bit, if you add, there is a chance that you may get 17-bit as the carry. So if you declare DCDW in the sum, okay, carry you cannot display. So you have to declare DCD for sum. Even for this array data also, you can write DCD only, no problem. but they are specifically given that add array of 16 bit. So you can write dcw. W means word length, it is 16 bit. So load R0 with the address of the array, load R5 with the address of sum. Okay. So this is for writing some answer to this location. Move R1 is equal to 0. Okay. Move R1 is equal to 0. Move R4 is equal to immediate data of 0. Compare R1 is equal to 10 because we are adding 10 16-bit numbers. So we have to keep a counter how many numbers we added. So compare R1 is equal to count. So this is a counter for number of digits we are adding. How many numbers we have to add? 10 numbers. So initially counter is equal to 0. After addition of each, we have to increment R1. Or you can initialize with 10 every time. You can decrement with 1 and you can compare whenever it becomes 0. Either way you can do. So in this program, we are using R1 is equal to 0. And after addition, you can see it add R1 comma R1. So this is actually after addition, we are incrementing that R1 is equal to R1 plus 1. So 10 times you have to add. Initially, the sum is, okay, initially sum is actually stored in R4 and initially it is 0. Initially sum is equal to 0. So compare R1 is equal to 10. 10 times we added or not, 10 numbers we added or not, we have to compare that R1 is equal to hash 10. If R1 becomes 10, then we have to stop because we have to add only first 10 numbers. So first 10 16-bit numbers stored in the array. So compare R1 is equal to as 10. If it is equal, you have to stop and you have to store the answer. First, you have to get the address. You have to get the address of sum. You can write these instructions in the beginning, or you can write here also. Okay, that is left to you. Even you can write in the beginning also, no problem. Or you can write at the end also. Both are correct. Okay, not change. So after that, next you can say here load register H. Here H stands for off word. LDR means full 32 bit. LDRH means you have to load off word. That means only 16 bit into R3. So R0 is having address of array. From that address, okay, we are getting the off word. So that means your left side, if something is there, it will pick only the first off word means only this. This is the 16-bit data. So off full word means 32-bit. Off word means 16-bit data will be taken to R3. After that, it will be incremented by 2. So why it is incremented means because it is declared as word. Suppose it is declared as, suppose this is declared as DCD, then this one you have to make it as 4. Since it is declared as DCW, you have to increment by 4 so that next it will point to next 16-bit data. So after that, you have to add R4 along with R3. R4 is initially 0. Okay, R4 is initially 0. So you have to add R4 with R4 is one of the operand plus R3 plus carry bit. Carry bit is actually 1 bit information. Okay. So you can see here ADC. ADC means add along with the carry. So R4 is equal to R4 plus R3 plus carry bit. So initially R4 is 0 and we have taken the first data to R3 LDRH R3 comma bracket R0. So first data that is 11 0x0011 is taken to R3. Okay, that will be added with 0 plus previous carry is 0 only. So the new answer again will be in R4. Destination register is R4. Okay. After that, since we added one data, you have to increment R1 by 4. So first we added this now. So you have to increment the R1 counter to by 1. So after that, next loop B next. Okay. Loop is a label. Okay. Loop is a label. Branch to next. Okay. Branch to next loop. I think if it is not used, you can remove that loop label. You check whether any loop is used. Yes, I think it is not required. You can remove this loop. Okay, branch to next. Okay, unconditional branch to next. So after that, we incremented R1 by 1 now. So you have to compare R1 with 10 or not. If it is equal to 10, you have to stop. That means you have to load the sum value to this R5 location, which is R5 is loaded with the address of this sum, and you have to store that R4 sum value present in that into this location, and you have to stop. Stop B stop means it will infinite time it will repeat here only. Okay. So next time it will increment again that it will take the new value of word to R3 and increment by 2. Why it is 2 means since we are loading half word, next half word is load half word. LDRH means load half word. Half word means only 16 bit. Okay. Load half word into R3 from address specified by R naught. After R naught is R, R naught is incremented by 2. Why 2 means because it is we are loading half word, so you have to increment by 4. If it is a full word, you have to in order to go to the next data, you have to increment by 4. Okay, hash 4 you have to write here. Hash 2 is sufficient. So this will repeat every time. It will add this one increment R1, add this one increment R1. So like that, by that time it reaches FFFA, it R1 value becomes 10. When R1 value becomes 10, it will stop, and the answer will be always stored in where ADC R4, R4 3. So here in R4, sum will be there. So store R4 content to the address specified by R5. In R5, we loaded the address of some variable. From R4, we have to store into this location. So you can check the answer in sum, which is declared in the result area, which is data type and read write type. So this one, you save it, compile it. So 0 errors and 1 warning, you can ignore. After that, you start debug. So it will go to the startup file with the line number 131, load R naught with address of main. In our program, we used underscore main. So it will fetch that address and it will jump. BX means branch to that address. So it will, within 2 steps, it will come to our main program. So load R naught with address of array. So what is the address of array? 122. So in the memory number 2, you type 122, you will get the data which is 011 0333. You can observe only half word. Okay, you can see here 0011 is first half word, 0022 is second half word, 0033 is third half word. You can see, I think you can click it as half word. Let me check whether it is possible. Short, I think you have to give unsigned instead of long, you can click short. Yeah, you can see here. This is 122 location, 123, 124, 125, like that. So 122, this is 123, this is every 2 bytes. Okay, 122, this is 124. You can drag this and you can see only one at a time. See here, in 122 we have 0011. Next half word is at 124, 0022. Next 126, 0033, 128, 0044. 12 in hexadecimal after 9. A. Okay, 12A this address, 12B this content like that. Okay. So in order to go to the next data byte, 2 should be added. That's why here hash 2 is there. If it is a 1632-bit data, hash 4 should be required. Okay, now first you have to load the address, that is 122. Next next is move R1 is equal to 0, R4 is equal to 0, compare R1 with 10. So if it is not equal, Z flag is 0. Only if it is equal, Z will be 1. Otherwise, it is not equal to 0. So if it is equal, store or stop. Otherwise, we have to next instruction it will be executed. Load of word R3. R3 will be loaded with first of word which is 0011. Let us see. Yeah, it is loaded with 0011. Upper bit will be 0 only. You have to consider only the first 16 bit. Remaining will be zeros only. So after that add with 0. The carry bit is also 0. You can see here. It will add with carry 0. So after that, you have to increment R1 by 1. R1 is equal to 0 initially. Now it is, we added one data now. So it is incremented by 1. Next, branch to next. So here, compare R1 is equal to, whether R1 is equal to 10? No. So no means only if it is equal, it will go to store. Otherwise, again, it will load R3 with next data, which is 22. You can see here in the memory 2, 22. That is 124 is the address here. You can see. See, after loading, you can see 124 becomes 126 because it will add a post increment by 2. Okay, it is 124 now. Second number will be 124. It converted into 126. Whenever it is executed, it will be highlighted with blue color 126. And second data 22 is loaded into R3. Next, it will add R4 contents here. R4 is 11 previous sum. It will add with the 22. It becomes 33. Okay, and carry is also 0. So it becomes 33. Okay, and branch to next once again. Again, it will add R1 to this one. So compare R1 with the 10. R1 is still 2 because we added only two numbers 0011 and 0022. Still we have to repeat 8 times. Okay, so this will repeat. This will repeat. You can observe the value of R1. R1 is 7 now, R1 is 8 now, R1 is 9 now, R1 is 10 now. Okay, A means 10. So now actually if you check the comparison, okay, if you check the comparison, compare R1 is equal to 10, Z flag will be become 1 because Z is 1. So that time when it is equal, it will go to store. Look, this will come to 14th now. This control will come to 14. So it will load the address of sum. What is the sum of address is 0x100 in the another memory window. So this now will drag here. So there are two memory I already opened. You can open four memory windows: memory 1, memory 2, memory 3, memory 4. Okay. So in memory 1, I think 0x1000 you can type 0x followed by 70 second type. This is to check our starting. I told where the data is stored. Okay. In the memory, you type 0x170. Press enter, it will get this. Okay. Now the answer we got is 136. So that 136 should come here. So now it will store that R4 content to this location. See 10, yeah, it is in R4, right? Right, sorry. ADC, R4 is the destination. It is 102A7. So you can verify the answer. We added all the bits now. So you can see, will show all the answer here. You can see calculator or you can also see use a system calculator. go to programmer and you can add all the data. So you can go to mode 4 is the number base and go to the hexadecimal mode. In the hexadecimal mode 1 1 plus 2 2 plus 3 3 plus 4 4 plus 5 5 plus 6 6 plus 7 7 plus 8 8 plus 9 9 plus AFF AA. Why I had given FFA means in order to show the carry also last number F5 have taken. So definitely carry will be there, sum will be greater than 16 bit. So answer is 1 0. See 16 bit for 16 bit is 0 to A1. So this is extra one. So that's why we are storing the answer in 32 bit BCD. Okay. So 1 0 to A7 is the answer. And if you convert it to decimal, you'll get 66215. You can check this one also by converting into decimal 125. Normally, all the values will be stored in the hexadecimal only. So if you don't want hexadecimal, the decimal, you can see the answer in this one. This is how to find sum of first 10 16-bit data present in the memory, or you can also you can convert this program to 32-bit numbers also. For 32 bits, you have to change this one LDR only. This one should be changed to 4 instead of as to 4. This LDR instead of LDR-H, it should be LDR only. Okay. If you want to add only 5 data, then you have to compare with 5. Okay. Compare R1 with how many data you want to add. So you have to add, you have to compare here. You have to add first 10 numbers, whether it is half word or full word. We have to add only first 10 numbers. Okay. 10 numbers we need to add. That's why. If you want to add 5 numbers, you have to give 5. Thank you.